Good morning, this is Keith Kenyon, and I'm going to show you how to solve some math problems from the worksheets here for Jaren. So I've never done a video like this before, but we'll see how it goes. I'm kind of excited to see how well this turns out. So give me a second here to get this shared correctly. I think I've got this right. All right. So I'm hoping you'll be able to see everything and understand everything clearly. So this is one of the first problems on one of the worksheets. It's -9 equals -3x minus 6x. And we're just going to solve this. So when we're looking at a multi-step equation like this, and I've got variables that are on the same side like this, I can combine them together. So the -9 here just stays by itself. And then these two terms, because they're just like each other, they both have an x with them. I can combine them together. So a -3x minus 6x would be -9x. So I just combine those together. And then I'm left with -9 equals -9x. So in order to get x by itself, I'm going to divide both sides by -9. And I'll get x all by itself, like this. These will cancel, the -9s will cancel, and leave me with just x on the right-hand side. And then -9 divided by -9 is +1. So for this problem, x should equal 1. Now, to make sure that I've got it done right, I'm going to go back and check my answer. And that's one of the things I expect students to do, is to go back and check their answer. So I'm just going to plug 1 back in. So in this case, -3 times 1. And subtract 6. And again, my x is 1, so I plug in a 1. The -9 stays -9, so my handwriting is not the best. Hard to do with a mouse. -3 times 1 is -3. And 6 times 1 is 1, but I've got a negative in front of that. So I do the 6 times 1 first to get 6, and then the minus comes along. This becomes -3 minus 6. And -3 minus 6 is -9. So I've got this one done correctly. So I can move on to the next one. So here I've got -2 equals 1 plus 2n minus 5n. So in this case here, I want to get the terms that are like each other combined together. I'm going to combine these two together first. So my first step is going to be to combine them. So plus 2n minus 5n is going to be minus 3n. So 2 minus 5 is -3, and then I have the n's with that. Now I'm left with -2 equals 1 minus 3n. My goal is always going to be to have the variables on one side, which in this case is the n, and the numbers on the other side. And then right now I have a 1 on the right-hand side, so I need to move that over to this side because the n's are over on this side. So I'm going to subtract this 1 on both sides. Those will cancel. -2 minus 1 is -3. All right. And this -3n still stays here. One of the concerns I have are students, they get rid of that negative in front of the number here when they get rid of a number like this. So I tell them, don't genie away the negative. So make sure this negative still stays and comes down. And then I got to get n by itself. So I'm going to divide both sides by -3. Those go away. And -3 divided by -3 is 1. I think the last problem was 1 as well. And now I'm going to plug it back in and see if I'm right. You make mistakes, so let's see if I got it right. So 2 times 1 will be 2, so I'm just going to put that in like this. And then 5 times 1 is 5, so this will be -5. So -2 is still -2. 1 plus 2 is 3. And 3 minus 5 is going to end up being -2. So I've done this one correctly, and I can move on to the next one. Okay, so this one's a little bit different. The x's are not next to each other. But in the same case here, I still want to combine the x's together. So this x is here and this x is here. So I'm going to combine those together first. So 6x plus 4x will be 10x. and then minus 1. Okay, so this negative 1 just comes down with this, and then I just combine my two x's together. Again, my goal is to have the x's on one side and the numbers on the other side. So I have a negative 1 by my 10x. So I'm going to add the 1 first. This is going to cancel and leave me with 10x on the right-hand side. On the left-hand side, it's going to be negative 11 plus 1, which is negative 10. And then I'm going to get x by itself, so I'm going to divide both sides by 10. And this is going to cancel and leave me with x. And then on the left-hand side here, negative 10 divided by 10 is negative 1. So in this case, x is negative 1. And now I'm going to plug it in and see if I've got that right. So I've got negative 11 on the left side. 6 times negative 1 is negative 6. And 4 times negative 1 is negative 4. And negative 6 minus 1 is negative 7. And negative 7 minus 4 is negative 11. So I got this one right. And I can move on. Okay, so this one's kind of one of these tricky looking ones here. So I have negative 6m minus 6m equals 0. So again, they're both on the same side, so I'm going to combine them. Negative 6 minus 6 is negative 12. All right, and again, I want to get m by itself, so I'm going to divide now by negative 12. This looks a little weird. Negative 12's cancel, leave me with just my m. And then 0 divided by, oh, oops, I missed the negative there. 0 divided by negative 12 is actually 0. So m is going to end up being 0 here. Kind of a weird looking problem. And now when I go to plug this back in, maybe I'll show actually plugging it in, because this one looks a little weird. So negative 6 times 0 is 0, because anything times 0 is 0. And then again, same deal. 6 times 0 is 0, but there's a minus there, so it'll be minus 0 is 0. And 0 minus 0 is 0. So a weird problem, but it ends up in this case m equaling 0. Okay, this one's different than the ones I've shown before. Here the x's are on different sides of the equation. And then how do we solve them when we've got this situation here? So again, when we're trying to solve equations, we want the variables on one side and we want numbers on the other side. And since I have a number here on the right, my goal here would probably to put the x's over here on the left-hand side. So I'm going to cancel and get rid of this 2x, or I'm going to move the 2x over to the side. I'm going to try to get the x's over here, keep the numbers over here. In order to do that, I've got to do the opposite of what the number is. So in this case here, I have 2x. And if I want to move it over to this side here, since this is a positive 2x, I need to get rid of it. I'm going to subtract 2x on this side, and I'm going to subtract 2x on this side. And these 2x's then will go away. They cancel each other out. 2x minus 2x, and they go away. 3x minus 2x is 1x, or just x. And then the 50 stays here on this side. And if I just end up dividing by 1, or I could have gotten rid of it at this case, because I know 1x and x are the same thing, and get x equals 50. And now when I plug that back in, I go 3 times 50. Get that. And 2 times 50 plus 50. So 3 times 50 is 150. And 2 times 50 is 100. And then I add to that 50. That's going to be 150. So in this case, I got it right. Okay, and that's how we do that type of problem. So I'm going to show it here a little bit more complicated. You'll notice I've got x's and numbers on both sides of the equation. and the goal is to put the x's on one side and to put the numbers on the other side. I usually do my x's first, but that's not necessary. I just like to try to clean up my variable before I try to do actual numbers. And I usually try to keep my x's either on the left or positive. So in this case here, I'm going to want to move this 3x over to that side of the equation. So I'm going to have to do the opposite of negative 3x. So in this case, the opposite of that is going to be add 3x. And try to get those to cancel on the right and see what we get here on the left. So these 3x's are going to cancel. Negative x plus 3x is 2x. And then these were canceled, so that just leaves me with a 6. Okay. Now I'm going to move the negative 4 over to this side, so I got to do the opposite of that to move it. So I'm going to add 4 to both sides to get it to cancel. So I have 4 here and 4 here. Those are going to cancel. Leave me with 2x on the left. And then 6 plus 4 is 10. And now at this stage, I can get x by itself by dividing by 2. And x equals 5, then 10 divided by 2 is 5. So now I'm going to plug things back in and see how they go. So negative x would be then negative 5, since x is 5, minus 4 equals, and then negative 3 times my x. Hope the clicks aren't really annoying. I'm sorry about that. Negative 5 minus 4 is negative 9. Negative 3 times 5 is negative 15. And then I add 6 to that. So negative 9 stays negative 9. And negative 15 plus 6 will be negative 9. So I got this one right as well. Okay, so we're going to look at another problem like this where we've got x's on both sides. So again, I'm going to try to get the x's on the left, and I'm going to put the numbers on the right. So I'm going to move this 2x over to that side. I have to do the opposite of that, which is going to be subtract 2x. Again, I'm trying to get them to cancel. So I subtract 2x here and here. Those cancel. Left with negative 30. 4x minus 2x is plus 2x. And then since those are canceled, that just leaves me with 12 on the right-hand side. So I've got the x's now on the left. I need to move the numbers now to the right. So I've got to move the 30 over to this side, or the negative 30. So I'm going to do the opposite of that to cancel it. So I'm going to add 30. And those cancel away. And that leaves me with 2x on the left. And then 30 and 12 added together is 42. Okay. And now to get x by itself, since it's 2 times x, I'm going to divide by 2 to get rid of that. And those cancel and leaves me with x is 21. So I'm plugging this back in. This is going to be a little bit more work because that x is such a large number. So here we go. So negative 30. I probably have to use a calculator. And then I'm going to have 4 times 21. I plug that back into x. And then I'm going to have 2 times 21 plus 12. All right, so negative 30 stays negative 30. 4 times 21 is 82. And 2 times 21 is 42. Plus 12. Negative 32, or negative 30 plus 82 is 52. And here I've got 42 plus 12 gives me 54, so I have a problem somewhere. Oof. So what did I do incorrectly here? It's kind of embarrassing making a mistake like this. I'm going to add 30, 42, 30 plus 12 is 42. Apologize for this. Oh, there's where I made my mistake, is when I plugged it back in. Oh, that's embarrassing. 4 times 21 is 84. Oh, bad, Mr. Kenyon. I'm sorry. 4 times 21 is 84. Negative 30 plus 84 is 54. So that shows one of the examples of why you want to check your work. Make sure you got it done right. In which case I did a good job of solving the equation, but a bad job of multiplying 4 times 21, so I should have used the calculator. Oh, bummer. Okay, so the last problem I want to show you is what we've been working on this week, which is rewriting equations. When we rewrite equations, or I say to students to solve for y, I just need to get y all by itself. So it's got to be y by itself. And we're not going to get a number with this for an answer. We're just going to get a different equation. So in this case here, I just want to get y by itself. So anything that's by y needs to go away. So in this case here, I have y minus 15 equals x plus 34. And I'm just going to get rid of what's around the y. So in this case, I have a negative 15. So I'm going to add 15 to both sides. All right. And those there are going to cancel and leave me with my y. And the x just goes by itself here. And then 34 plus 15 is 49. And that's it. We're done. There's nothing else to do with these problems. As long as I have y all by itself, then there's nothing else that I need to do with it. Now, if it ended up where I had like a 2y equals something, then I would divide things by 2 to get the y. But in any one of these problems that you have for rewriting equations, the y has to be all by itself. I don't think I did another one, but maybe it'd be a good idea to show another one. I'm just going to pick another one on here just to give you an indication. So here, this is one of the problems from a worksheet. I got 28 equals 7y minus 14x. And again, I want to get y by itself. And when I'm also solving for y, I want y on the left-hand side of the equation. So I can either move it now or I can move it later. In this case, I'm going to move it later just because that's just one thing it seems like most of my students are doing right now. So right now I've got something by the 7y here, and I got this negative 14x. I'm going to do the opposite of it. I'm going to move it over to this side of the equation. I'm going to move it over to that side of the equation by adding 14x. One of the concerns I've got with this when students are doing this is that, so those will cancel there. One of the concerns I've got is that students will try to combine these together and make like 42x, but they're not the same type of thing. So they can't go together. So I'm going to go 14x, which is positive here, and then plus 28. So they don't combine. They're not the same thing. Okay, so now got 14x plus 28 equals 7y. I'm going to need to divide everything by 7 to get this y all by itself. So I'm going to get rid of that number in front. And when I divide, I have to divide everything by the same. I got to do the same thing to everything, otherwise it won't work out. So the 7's here will cancel. I'm left with y. 28 divided by 7 is 4. And 14x divided by 7 is 2x. So now my equation looks like this, and I've got y by itself, which is good, but we usually write that first. So in this case, I'm just going to swap them. I'm going to move the y over to this side and just leave it as y, and I can just do this. This is a legal math move, and I can put the 2x plus 4 on the other side. So I just swap sides, and that's how we would do that one. So there you go. There's a video showing some solved problems, including a mistake by me. I'm embarrassed by it, but I guess it is what it is. So hopefully these problems were helpful for you to take a look at. And if you have any questions, you can give me a call at school, or you can give me a call at home. I guess we'll see how things go. Keep me in the loop. So thank you very much for watching. I appreciate it, and hope it was helpful. Thank you.